Right, the domain is the x values, so we just write d equals, and our x's are 3, I'm going to put them in order, negative 3, 3, 4, and 8, and our range is the y values, again in order, 12, 2, and 6. The question about whether it is a function or not is pretty easily answered by looking at the original relation up here. If we look at that relation, we just have to make sure that we don't have any x values, domain values, going to two different range values. But here, since all of our x's are unique, none of them are repeats, it certainly is going to be the case that this thing is a function. So we write function or yes to indicate that it is. Alright, second one, this one, same question, except we have a lot more points. We have so many points, instead of drawing it or writing it out in a set of points like we did in problem number 1, we've just drawn a graph of it. Remember, a graph or a line like this is just a set of infinite points. So let's worry about the domain first. Alright, now because we have so many points we can't list them, so we're going to have to write some sort of inequality or an expression of some type, an equation of some type to indicate. And to do this, we'll look at our x-axis. Remember, x is on the horizontal axis. And we can see the lowest point our graph goes to. And the x-axis is right there, and that's at negative 1, 2, 3, 4, 5, 6, 7. So at negative 7, our graph stops going left. And then on the right-hand side, in the positive direction, it goes forever to the right. So we'll just say, well, all the x's greater than or equal to negative 7 are used. Okay, for a range, let's pick a different color here for range so we can kind of see it. Here's a blue color. That's our y stuff. We say, well, what's the lowest the y goes to? And the lowest it goes to in the y is right down here, and that's at 1, 2, 3, 4, 5. So it goes down to negative 5. And then as far as how high it goes 1, 2, 3, 4, 5. It goes up to 6. And then it levels off. It doesn't go any higher than 6. So our y values are trapped in between negative 5 and 6. So we write that down. We say there's where the y values are. They're less than 6, but they're greater than negative 5. And they are equal to both those, so we'll go ahead and throw those equal signs in there. Is it a function? We just apply the vertical line test. The vertical line test says, can you draw a vertical line anywhere that hits it in more than one point? And any place I draw a vertical line, it only hits it in one single spot. So just like the previous one, this is a function. Next one, find the slope of this line. Remember, slope is change in y for a change in x. Okay, if we want to see that as points, we'd say y2 minus y1, or x2 minus x1. It's just change in y over change in x. I usually call this x1 and y1 because that comes from the first point. This x2 and y2 because that's the second point that I was given. And I go negative 8, y2 minus negative 6, which is y1, and I go x2, which is 2, minus 3. And that gives me my change in y and my change in x. This you want to be careful of right here. Okay, that double negative, that creates a positive for us, so it's negative 8 plus 6 over 2 minus 3. Negative 2 over negative 1 says a slope of 2. And we're done with 3. Problem 4, what's the slope of vertical line? You better memorize this. Slope of vertical line is undefined. Can't do the math and tell you a number on that. Gives you a division by 0. What's the slope of a horizontal line? Again, memorize that. It is just 0. It has no slope at all. Problem 6, slope of this line. This line is given to us as an equation. We could find 2 points on it and use the slope equation, but it's easier 2. Subtract 4x from both sides. Tuck that 4x, negative 4x right behind the equal sign. Divide everybody by 3 to get the y alone. And you've put it into slope-intercept form. Okay, that's y equals mx plus b. And then by inspection, we can see the m value must be negative 4/3. By inspection means just by looking at it, we can see what m is. Problem 7, some function evaluation stuff. Okay, we are given f of x, they want the f of 5. So we write f of 5 is, and we write down f of x, but the x is now replaced with a 5. And then we evaluate that. That's 4 times 25. Remember, squaring goes first, order of operations. 100 minus 3. So f of 5 is 97. You can write it just the way I have it, or at the very end you can put f of 5 equals 97. Next problem, f of negative 2. We do the same thing, except now we're plugging in negative 2 for x. And so that equals, again we square negative 2. Make sure you do that right on your calculator. It's a positive 4. That's 16 minus 3. That's 13. So the f of negative 2 is 13. And then lastly, f of 2x. f of 2x, we plug in 2x for x. So it goes 4. Instead of x, we put 2x and then square it, minus 3. Okay. Again, we square first. That's a 4x squared. Notice the parentheses are gone. I squared the 2, so I don't have it squared above that, but the x is squared, so I have to write it that way. That gives me 16x squared, multiplying it out, minus 3. And that's how you evaluate functions. Problem number 8. Write an equation in slope-intercept form. We'll always put that in there, or assume that, with a slope of negative 3/4, and then it goes to the point 10, negative 4. Okay, well, if we know the slope, we know almost everything we need to know to write this equation. The only thing we don't know is the b value, the y-intercept. Okay, we could graph it and try and take a look at it, but instead of doing that, we know those have to make the equation true. That's our x and y values. So if I plug in a negative 4 for y, and I plug in a 10 for x, 10 for x, I can solve that and find out what b is. Okay, we had a problem with that today. A lot of people were doing this step and then messing up or making a mistake when they tried to figure out b. So negative 3/4 times 10 is negative 30/4. And then our next step is we're going to add 30/4 to both sides. On the right hand side, it makes 30/4 disappear. So I'll go ahead and show you all the math here so you can see it. I'd get out my calculator at that point, but we'll get a common denominator. Negative 16/4 is the same as negative 4. And I'm adding that to 30/4 to figure out what b is. And so I get 14/4, which is 7/2 is b. Now don't forget to write your final equation. Our final equation is right up here, but we have to plug in that b value. So our last step, I'm going to erase a little bit here to give us some room. Okay, so our last step again is to rewrite that equation that we started earlier, but now not only do we know the slope, but we know the y-intercept. So there's the equation of a line with a slope of negative 3/4, and it goes through 10, negative 4. You could check that, plug in a 10 for x, and see if y is negative 4. Problem 9, we have to be parallel to this equation, y equals 2x minus 3. Hey, if we're parallel, we have to have the same slope. So we're going to use the slope of 2. So now we have, write the equation with a slope of 2 that goes through 3/4. Same as the previous problem practically. We have y equals 2x because I know m. I just have to figure out what b is, so I plug in a 4 for y and a 3 for x, and I work out the math to figure out b. Subtracting 6, 4 minus 6 is negative 2, and now I've got my equation. Y equals 2x, that's my slope. Same slope as the first line because they were parallel, and there is my y-intercept. Problem 10, write the equation of a line perpendicular to this line. Well, this line has a slope of negative a half. Therefore, the slope of a perpendicular line is the negative, or opposite, I prefer to say, reciprocal of that. Well, the opposite is going to be positive. The reciprocal is going to be 2 over 1. And we don't write the plus sign, we don't put the 1, we just say it's going to be positive 2. So the equation now is y equals, I know the slope to use, plus b. And an added benefit is this point right here is the y-intercept. That's the b value. When x is 0, the y value is the intercept, and that's my equation. 2x plus 5. If you did not recognize that, if you said, well, y equals 2x plus b, I've got to find b, great, plug in 5 for y, 0 for x, and you'll see this term just cancels out because 2 times 0 is 0, and you find out b is 5. Regardless of how you do it, you end up with that equation. Okay, so pay attention because that can make problems much quicker for you sometimes. Problem 10, we have to graph a couple of lines here. I'll do the first one in blue color. Y-intercept, negative 2, that's right down there. Then it says go up 1 over 3. There's my other point. And grabbing a straight line here, hopefully. Let's use that color again. Let's see if I can get through those 2 points. There we go. It looks something pretty close to that. We'll use red for this guy right here. First thing, get him in slope-intercept form. There we go. We gotta have that x term right behind the equal sign. So my slope is negative 3 and my y-intercept is 4. So I marked my y-intercept first. He's at 4 right there. And I go down 3 and over 1. So there's another point. You could also go up 3 and back 1. Either way, you're going to get the same result. And then I'll sketch that line in there. Looks something like that. So that is part B. And I believe, yep, that's all of our slides. So if you study these, you should be in pretty good shape. It's not everything that's on the quiz, but that kind of is the gist of what we are trying to cover.